I'm Anil Kumar, and in this video we'll learn few techniques of sketching derivative of a function from the given graph of the function. So the question here is sketch graph of derivative given graph of polynomial function. So here is a polynomial function. As you can see, it seems that the polynomial function is of order 3. So we could say this given f of x is cubic in nature, right? So that is from the behavior of the function we can make out it is cubic in nature. If the function is cubic, what do you expect from the derivative? In that case, the derivative should be quadratic, right? So degree 2, it should be quadratic. As you know, for polynomials, whenever we find the derivative of any polynomial is 1 degree lower than the degree of the polynomial itself. So that gives us an idea that the graph of the derivative should be quadratic function, right? Now what else do you notice here? Now from this behavior, what do you think is the leading coefficient of this cubic function? As the right side is up, we can say that the leading coefficient is positive. So it has positive leading coefficient. So if it has positive leading coefficient, in that case, the quadratic function should also have positive leading coefficient. You can see from the graph that on the left side, if we draw a tangent line, then it has a positive slope. That means that the left side of the graph should be having a positive value. So a parabola on the extreme end, as it approaches minus infinity, is actually positive. So that means right side. And also on the right side, we have the tangent, which has a positive slope. That means the derivative will be positive when it is approaching, when x is approaching positive infinity, or even when x is approaching negative infinity. So in both the cases, what we see is that the parabola should be positive, right? So it is approaching infinity on both the ends. Now we will use the information about critical points to get some more insight to our derivative function. Now critical points are the points where the tangent is 0 or undefined. Now here we have two turning points, right? So one is right there at x equals to 4. The other one is at x equals to 0. So at these turning points, the derivative is 0, right? So at x equals to 0 and at x equals to 4, we have turning points. Now these turning points will translate into zeros of the derivative. So these are zeros of derivative, correct? So there are two zeros which I could now mark for the derivative of the function. So one zero will be at x equals to 4, the other one will be at x equals to 0. Now if it is a quadratic function with two zeros, a parabola opening upwards, then we have got most of the information to sketch the parabola. What we may like to figure out is what is the minimum value of this parabola, right? A parabola will have a minimum value. To find that value, we can look for the center value, which is the axis for the parabola, in this case x equals to 2. So the point on the curve at x equals to 2 is marked now. If I draw a tangent at this point, I will get from the slope of the tangent the value of quadratic function at x equals to 2, right? So let me sketch a rough tangent here. So whenever we are trying to find graphical solutions, most of the time they are, I should say, approximate, right? So very close to the real, but they are approximate. The advantage here we have is we can actually understand the concepts better, right? So let us say this is my tangent, and let's find slope of this tangent, right? So approximately, let us say this point, and we can take this point is slightly away from 1. So let me take a point which is slightly away from 3, and let us say it is here. So what we can say here is that the rise is each unit is 5 here. So from here 5, 10, 15, 20, 25. So the slope at 2, so we can write slope at x equals to 2 is approximately equals 2. So from here to here we can form this triangle. So we have this rise which is negative from -5 to 30, which seems to be, this is up to this place, right? So we are just moving slightly away, so this is the point for us. Okay, so we'll assume this at -30. Okay, that is fine. So rise is -30 minus 5. So minus of -5, that will make it +5, divided by the y values. We can take this as slightly more than 2. So let me take this as let us say 2 itself. Okay, slightly more than 2. So we are just approximating it. So that gives us around -25 divided by 2, which is -12.5, let us say. So that means the value for the minimum value for the parabola is -12.5, right? So approximately the derivative of this function will have a minimum at 2 whose value will be around 12.5. So let us say this is our 12.5. Now, knowing these two x-intercepts, the zeros for our derivative and the minimum value, we can always sketch the parabola, right? So let me sketch this parabola. Now that should be kind of like this, right? So it is that kind of a graph, which is a parabola, and that represents the derivative of the given function. Do you get the idea? So from the slope at the midpoint on this curve, we get approximate value of minimum, right? So we got minimum, that is the minimum on the derivative of the function. So knowing these two x-intercepts from the turning point of the function and the minimum by finding the slope midway between them, we could sketch the graph of quadratic function, which is fairly accurate, right? So that is how you can actually sketch the graph of derivative, especially for a cubic function, as we have shown here. I hope that helps. Thank you, and all the best.